Exploring the Universe, a dialogue on space science. Characters: Mr. Thompson, teacher. Alice, curious student. Ben, skeptical student. Clara, enthusiastic student. David, analytical student. Scene 1, Introduction to Black Holes. Mr. Thompson.
Good morning, everyone. Today we are diving into one of the most mysterious phenomena in the universe, black holes. Are you excited?
Alice.
Absolutely. I've always been fascinated by them.
Ben.
I don't know. Black holes sound terrifying. Like they just swallow everything up.
Clara.
That's exactly what makes them so interesting. They defy our understanding of physics in many ways.
David.
I agree. Studying black holes helps us comprehend the extreme conditions of the universe.
Mr. Thompson.
Excellent points. Now, let's start with the basics. What happens to a star when it runs out of fuel?
Alice.
It collapses, right?
Mr. Thompson.
Exactly. Depending on its mass, a dying star can turn into a white dwarf, a neutron star, or, if it's massive enough, a black hole.
Ben.
So black holes are just the remains of really big stars?
Clara.
Yes, but their gravity is so strong that not even light can escape once it crosses the event horizon.
David.
Which means we can't directly see black holes, only infer their presence based on their effects.
Mr. Thompson.
Correct. And speaking of effects, what do you think would happen if you got too close to one?
Alice.
Would we be able to feel anything if we were near a black hole, like being pulled toward it?
Mr. Thompson.
Good question. If you were far enough, you wouldn't feel much. But as you got closer, you'd start to experience stronger gravitational pull on different parts of your body, especially if you were approaching feet first.
Ben.
That sounds painful.
Clara.
That's spaghettification, right? Where you get stretched into a long string of atoms.
Mr. Thompson.
Exactly. The closer you get, the greater the difference in gravitational pull between your head and feet, stretching you out like spaghetti.
Scene 2, The Power of Gravity. David.
I imagine the gravity would be so strong that nothing could escape.
Mr. Thompson.
That's exactly right. The closer you get to the event horizon, the stronger the gravitational pull. It's so intense that space and time start behaving in bizarre ways.
Alice.
What would happen to a spaceship that got too close?
Mr. Thompson.
If it crosses the event horizon, it's game over. There's no coming back. Even before that, intense gravitational forces, known as spaghettification, would stretch anything into long, thin strands.
Ben.
That sounds absolutely terrifying.
Clara.
But also incredible. Imagine watching something get stretched infinitely like that.
David.
I have a question. How does time behave near a black hole?
Mr. Thompson.
Excellent question. This is where Einstein's theory of relativity comes into play. Near a black hole, time slows down dramatically due to gravitational time dilation.
Alice.
So if I traveled close to a black hole and came back, I'd be younger than my friends?
Mr. Thompson.
In theory, yes. This concept is called time dilation, and it has been experimentally confirmed in less extreme conditions with high-speed travel.
Ben.
Does that mean black holes could be used for time travel?
David.
In a way, yes. If someone stayed near a black hole for a while and then returned to Earth, they would have aged much less than the people they left behind.
Clara.
That's just like in science fiction movies. Could we ever use black holes for interstellar travel?
Mr. Thompson.
That's a very interesting idea. Some theories suggest that if a black hole was connected to another point in space, it could act as a wormhole, a shortcut through space-time. However, there's no evidence that natural wormholes exist, and even if they did, they might not be stable. Now, let's use our imagination. Suppose you could travel safely to a black hole. What would you do?
Clara.
I'd take as many pictures as possible.
David.
I'd study the effects of extreme gravity on different materials.
Ben. I'd probably feel too scared and want to leave immediately.
Alice.
I'd want to explore everything. Imagine what we could learn.
Mr. Thompson.
Now, let's think historically. If black holes have been discovered centuries ago, how might that have influenced our understanding of the universe?
Clara.
We might have understood gravity much earlier.
David.
And perhaps we'd have better technology for detecting black holes today.
Ben.
Maybe if they were more common knowledge, I wouldn't be so afraid of them.
Alice.
I think more people would be excited about space exploration.
Scene 4, Recent Discoveries. Mr. Thompson. Alice.
I've read articles about them, especially the first real image of a black hole.
Clara.
That was taken by the Event Horizon Telescope, right?
David.
Yes, it was a major achievement in astronomy and proved a lot about general relativity.
Ben.
I haven't looked into it much, but I'd like to learn more.
Mr. Thompson.
That's great to hear. Black holes were once only theoretical, but now we have actual observational data.
Alice.
It's incredible to see how far science has come.
David.
And it raises even more questions about the universe.
Scene 5, Closing Thoughts. Mr. Thompson.
Sometimes, unexpected discoveries change everything we know about the universe.
Alice.
It's exciting.
Clara.
Yes, a single discovery could rewrite our textbooks.
Ben.
It's fascinating how our knowledge keeps evolving.
David.
And sometimes what we think is true today turns out to be completely wrong.
Mr. Thompson.
That's why we must always stay curious and open-minded. Black holes are a perfect example of how much there is still to learn.
Alice.
I feel even more inspired to learn about space.
Clara.
Me too. The universe is incredible.
Maybe I should face my fears and learn more.
David.
Together, we can uncover the mysteries of black holes.
Mr. Thompson.
That's the spirit. Keep asking questions and never stop exploring the wonders of the universe.
Scene 6, The Role of Black Holes in Galaxies. Mr. Thompson.
Now that we understand the basics of black holes, let's talk about their role in the universe. Do you know that black holes are actually crucial for the formation of galaxies?
Alice.
I thought they only destroyed things. How can they help form galaxies?
Mr. Thompson.
That's a great question. Scientists believe that supermassive black holes, which exist at the center of most galaxies, help shape them by influencing the movement of stars and gas around them.
David.
Oh, like the one at the center of our Milky Way, Sagittarius A*.
Mr. Thompson.
Exactly. This black hole has a mass of about 4 million times that of our Sun.
Ben.
But if there's a giant black hole in the middle of our galaxy, why aren't we being pulled into it?
Clara.
Maybe because we're too far away?
Mr. Thompson.
That's right. While its gravity is incredibly strong, our solar system is far enough that it just orbits around the black hole, like how planets orbit the sun.
Alice.
So, without black holes, galaxies wouldn't exist the way they do now?
Mr. Thompson.
That's the idea. They may play a key role in organizing matter in galaxies.
Scene 7. Could black holes be portals? Ben.
You mentioned earlier that black holes could be connected to wormholes. Does that mean they might be portals to other universes?
Mr. Thompson.
That's a fascinating concept. Some theories in physics suggest that black holes might be linked to wormholes, which could hypothetically connect different points in space and time, or even different universes.
Clara.
That sounds like something straight out of a sci-fi movie.
David.
But do we have any evidence that wormholes exist?
Mr. Thompson.
Not yet. Wormholes are purely theoretical at this point. We don't even know if they could remain stable long enough for anything to pass through.
Alice.
But if we could stabilize them, would that mean faster than light travel?
Mr. Thompson.
Potentially, yes. If a wormhole could be used as a shortcut between two distant points in space, it would allow us to travel across the universe in a fraction of the time.
Ben.
That would be amazing. But it sounds really complicated.
David.
And probably dangerous. If wormholes exist, wouldn't the extreme gravity crush anything trying to go through?
Mr. Thompson.
That's one of the major challenges. There are a lot of unknowns, but studying black holes helps us get closer to answering these questions.